Alright, let's focus on deletion. And now, when you delete in a heap tree, you can only delete the node. Again, when you delete in a heap tree, you can only delete the node. You cannot delete the parent or children below the node. So, how do you delete the node in a heap tree? You swap the root node with the last node. So we're going to delete 70. 70 is the value we're deleting. Alright, just hold up here. So here, and we're going to here. Let's get the eraser. So 1 is now 9. One is 9. And 9 is 70, last value. So let's make this one here. Let's do it to our tree. All right. And this will become 70. And 1 will become 9. Is this a max heap? No, it's not. Since all the parents below 9 is greater than 9. So what we have to do now is swap. Swap until the parent is greater than 9. So what we're going to do here is we're going to see if 50 and 40 is whichever is greater here on the right or the left side of the tree, we will swap with 9. It's also important to note that to get the left child and the right child of a tree, you will hear left child of a tree parent. It is I times 2, and the right child is I times 2 plus 2. Make sure this looks like a 2. Alright, add the parentheses just in case. So that's the equation. So we go down here and we say, okay, which one's greater, 50 or 40? 50 is greater. So we do a swap. I'm going to just change the color again. So we swap here. Now 50 is the root node. and 2. Let's make this here 9. Okay. Yeah, just make it okay. That looks like a 9. And to see it, so you go. This is what we did here. Is basically 1 times 2 equals 2, and we for the comparison, and then 1 times 2 plus 1 equals 3. As you can see, 2 and 3. So now we did the swap here. So 59, we'll make the swap here. Okay. And 50. All right. And then we do the same thing until the parent is greater than the value 9. So, all right, we're going to just go here. And we're going to see we're going to do a quick comparison. So, which is greater? 45 or 35? 35 is greater. So we do a swap. Let's do a swap here. Okay. This here 45 and 9. And 70 is deleted here, so we cannot access it. So just put it here for reference because it's an array. So can't access. So from 1 to 8 is the array, so we do so we're going to say that 10 is not in, 70 is not in the tree. All right. Just make that a 70 to be clear. Here. 70. That looks like a 70. So there is no right child for 9. So now we do the swap again in the array. So you can see here that it was 2. So you can see that I here was equal to 2, and which was 45. So you can say 2 times 2 equals 4. This is for the right child. Oh, crap. Left child equation here. Two times 2 plus 1 is 5. So you can see it here, 4 and 5. So in our array, we're going to swap 2 with 45. int 4, we're going to put 9. Now we go, okay, 9 is greater than 10. Sorry, 9 is less than 10. So we do a swap. Since the parents should always be greater. So we only have the left child, so it is 4. Since 9 is at index 4, times 2 equals 8. So we do the swap for the right child, sorry, for the left child. And we put 9 here, 10 here. Now we have our binary, our max heap tree.